Hey guys, welcome to question MM331 of the Maths Methods Fortify Study Guide. So, in this question we've got a function, f of x equals 20 outside of 1 take sine pi x on 30. It says Farmer Joe owns pigs and fills up their water trough each day. The cross-section profile of each end of the trough can be modelled by this function. All measures are given in centimetres. Cool. Where x is between 0 and 30. So we know that a tap sits on the edge of the trough and releases water at a rate given by dv dt equals 11t on 10, such that a total of v milliliters of water is released t seconds after the tap is turned. What is the rate of water flow 3 seconds after the tap is turned on? Awesome. So what we want to do is, this is our rate, like dv dt is always going to be a rate, and we know that it's 3 seconds after it's turned on, so we simply can sub in 3 for our t value. So we get 11 outside of 3 on 10, which is 33 on 10. Now it's really important to include units here. If you don't include units, you are going to be wrong and you won't get the mark. So our rate is volume, so milliliters, per second. So it's volume with respect to time. Awesome, that's our first and only mark for this question. Let's move on to part B. Part B is a 2-mark question, and it says, find an expression for the total volume of water V released by the tap at any time t, given that V of 0 equals 0. Cool. So again, we know that dV dt is equal to 11t on 10. We know to find an expression for V of t, we need to integrate or anti-differentiate our dV dt, right? Because this is the derivative of V. So, oops, 11t on 10 dt. From here, we can simply just integrate this as normal. So we get 11t squared, so we add 1 to the power and then divide by the new power. So we get 10 times 2, which is 20. Plus c there. And it tells us that v of 0 is equal to 0. Also, this is our first mark. We can't forget that c. If you don't include that, you're going to be wrong and you won't get full marks. So we know that v of 0 is 0, so 0 is equal to 11 times 0 squared over 20 plus c. So therefore, c equals 0, which means that v of t is equal to 11t squared over 20. That's our second mark. Now, I know that c was equal to 0, but if you didn't include it to begin with, and you didn't work out that it was 0, you will only get 1 mark. Okay, you have to show that you know that c is equal to 0 without just excluding it. So that's it for part B. Let's move on to part C. Part C is just simply a 1-mark question, so pretty straightforward. And it says, how much water will the tap have released after 20 seconds? Cool. So this is, again, a very straightforward question, as long as you figured out B. So we know that V of t is equal to 11t squared on 20, and we know that we're looking for the amount of water that the tap has released after 20 seconds. So we simply sub in 20 for t, so V of 20 is equal to 11 times 20 squared over 20, which gives us 220 milliliters, which is our first mark and only mark. So just make sure you include those units. If you don't include units, you will not get the mark. So just, yeah, make sure you do that. That's it for that question. Let's move on to part D. Part D, again, is a 1-mark question. And it says, Joe wants to calculate how long it takes for the trough to fill up so he can install a timer to turn the tap off automatically. He starts by measuring the depth of the trough, d centimeters. State the value of d. Awesome. So we're just looking for the depth of the trough from here to here at the moment. We know that this is a negative sine graph. We have no horizontal translation. We do have a translation of 20 units up. And we also have a amplitude of 20, right? Because if we expanded this out, we would get an amplitude of 20. Now, an amplitude is from the midpoint, which is this point here, to the bottom, which in this case is our amplitude, right? So 20. So our amplitude is 20, which means that our d is equal to 20 centimeters. So the depth of this trough is 20 centimeters. That's our first and only mark for that question, guys. There is in this question, there is a lot of 1-mark questions, or 1-mark parts, I should say. This is just designed to be kind of a simpler question. So let's move on to part E. Part E is a 3-mark question and says, he then finds the cross-sectional area of the trough a centimeters squared given by the area of the shaded region above. Find the exact value of A. Awesome. So we're looking for this area here, this shaded area. There's multiple ways we could do this. I'm going to do the rectangle method and then minus the area under the graph. So we've got this big rectangle here, if you can kind of imagine that, this rectangle here. We're going to find the total area of that rectangle, and then we're going to minus whatever's under the graph, and that's going to leave whatever's shaded here. So what we're going to do is say that the area is equal to the rectangle minus the area under the graph. So rectangle minus under, I like to say. In that case, we've got our rectangle, which is just length times width, and then minus the integral from a to b of f of x dx. Okay. Now the length of our rectangle is 30, and the width, or the height in this case, is going to be 20, right? Because our amplitude is 20, and we found that the depth of the trough is 20 centimeters. So we have 30 times 20 minus from 0 to 30 of f of x, which is 20. So out of 1 take sine of pi x on 30 dx. Awesome. Now we can just evaluate this. So our first mark actually does come here. So that's where we get our first mark. 30 times 20 is 600 minus, now the integral of all of this is 20 outside of x plus 30 over pi. So sine changes to negative cos. So this negative changes to a positive then. Cos of pi x on 30. From 0 to 30. Awesome. That's our second mark. Okay, so evaluating that is mark 2. And then we can just kind of keep evaluating this. So we get 600, take away 20 outside of, we sub in our 30, so we get 30 plus 30 over pi, cos 30 times pi on 30 is just pi, so cos of pi. Awesome. And then we're going to minus this with the zeros in there, but because this is a minus, we're going to plus it. Okay, so I'm just going to kind of skip that step there. So plus 20 outside of 0 plus 30 over pi, cos of pi on 30 times 0 is just 0. Awesome. So 600 minus 20 times 30 is 600. Negative 20 plus 30 on pi, cos pi is, so the 20 and the 30 on pi become negative 600 over pi. 600 over pi, and then cos of pi is negative 1. So we times that by negative 1. Then we're adding 20 times 0, which is just 0, and then 20 times 30 on pi, cos of 0. Okay, so we get plus 600 on pi. Actually, I can probably fit it over there, can't I? 600 over pi. Cos of pi is just 1, so we get 1 there. And then what we get, I'm going to have to write this on the line up. 600 minus 600 is 0. This negative 600 on pi and negative 1 become positive. So we get 600 on pi plus 600 on pi, which gives us 1200 on pi centimeters squared. And that is our third and final mark for part E. That's our cross-sectional area there. If you have any questions, let me know. But let's move straight on to part F. Part F is a 2-mark question, and it asks us, or it tells us, the trough is 1.2 meters long. For how long should Joe leave the tap running to completely fill the trough with water? Give your answer correct to the nearest second. Awesome. So we know that the length is equal to 1.2 meters, but we don't want to be dealing with meters, right? Because this trough at the moment, all of our measurements are in centimeters, so we want to change this to centimeters. 1.2 meters is the same as 120 centimeters, and so our volume, because a trough is like a prism, right? Because we're told that this function models each end of the trough, okay? So we can assume that it's the same all the way going along. So the volume of this prism or this trough is going to be this cross-sectional area, which is 1200 on pi, multiplied by the length, right? So it's this area here, and then we're going to multiply it by the length. That's just a kind of a general rule for prisms like this. So times 120. What this gives us is 144,000 over pi centimeters cubed. And this is our first mark, okay? So we figure out our volume, and then we're going to need to work out the time it's going to take the tap to fill up that volume, okay? So we know that our volume formula, because we figured it out before, is 11t squared over 20. and we know that we're trying to figure out our time when the volume is equal to this here, which means that therefore 144,000 over pi is equal to 11t squared over 20. And now from here, we can simply just solve for t. Just do as much working as you possibly can. So you get t squared equals 2,880,000. Wow. Over 11 pi. And then we can square root that, and we get t is equal to 288.69. And remember, you do have your calculator. You don't need to do that in your head. If you can, that's crazy and good on you. We're looking for the answer correct to the nearest second, which means that we need to round this up. So we get t equals 289 seconds. Don't forget your seconds, because we're dealing with time. We need to make sure we have our units. That's our second and final mark for this part and for this question, MM331. Guys, if you have any questions about this, as always, please hit me up in the comments below. But otherwise, thank you so much for watching, and I'll see you in the next video.